Hey calculus kids, this is Dr. Callahan with week 16 Thursday. How are you guys doing? Hope you guys are having a wonderful week. Go ahead and pause the video and answer the following 3 questions. Okay, so today we're going to go over this example right here that I found from the 2004 AP exam for Form B, and it's question number 6 with no calculator. And the question itself looks fairly simple, but actually it is fairly complicated. I thought out of all the ones that we've gone over, this one actually took me a little bit of time to kind of refocus and readjust and try to figure out how to go about solving for this one. But before we do that, here I have a cheat sheet, which you will be getting from my class on today. So if you are on the hyper day, make sure you grab a copy of this when you do show up. But this is basically the cheat sheet from Unit 1 all the way to the very end of Unit 6. So you start off with limits, different properties, evaluation techniques, continuous functions. And what I want you guys to do with this page is basically highlight the concepts that you feel like you still need to review and make sure that you understand them. Then we started Unit 2, which went on to derivatives and the different variations and the different techniques of simplifying derivatives. And it goes into implicit differentiation, the common derivatives that you do need to memorize, increasing, decreasing with concavity and critical points. Then we went into the extrema, which is the first and second derivative test, mean values theorem, and then also the Rose theorem. Then we talked about related rates, which I will have to go over another question that involves related rates on your free response questions. I haven't seen one that we've gone over yet, but I know there is one, so I'm gonna have to look a little bit deeper and find one. Optimization problems right here on max and min. Then we started Unit 4, which is on integrals and the fundamental theorems of calculus, the properties and the theorems, the common integrals that you need to memorize. And then lastly, we kind of ended it with areas and volumes. And so there are 6 pages essentially of a cheat sheet that you need to go ahead and take a look and highlight. So it's this concept I need to memorize. Make sure you summarize it with each of the 6 different pages. All right, with that said, let's turn over to this question right here. Go ahead and take a moment and get yourself acquainted with it. Okay, so it says let L, which is going to be this line right here, be a tangent line to the graph y equals x of n. Okay, so this is obviously a tangent. So this is going to be the L is going to be the slope to this equation right here at 0.11. So x equals 1, y equals 1, where n is going to be bigger than 1. As shown above. So the first part here asks you to go ahead and find the integral between 0 to 1 x of n dx in terms of n. So looking at this, the integral of 0 to 1 x of n dx is going to equal to, if you remember how to find the integral of something, you have to add 1 and then divide it by the exponent. So x to the n plus 1 divided by n plus 1. Evaluate it from 0 to 1. So let's go ahead and do the upper bound. Your upper bound is going to give you you got to remember that you're looking at this from the perspective of x, okay? So in term of x. So when you plug in the upper bound, it's saying x is equal to 1 and x is equal to 0. So your upper bound, you're going to have 1 to the n plus 1 over n plus 1. Minus the lower bound, which is 0 n plus 1 over n plus 1. Well, the second part of this is fairly easy because anything that's 0 is just going to be 0. So you could just cross it out, not, assume anything of it. But here you're going to do a little bit of thinking. You know that n is greater than 1. So let's say if n equals 2, for example, then you have 2 over 1 over 2 plus 1. If you take a look at this right here, what you essentially get at this point is anything to the 1 power is just going to be 1. So it doesn't really matter what n is, you're still going to end up with 1 as a numerator. In the denominator, it's just n plus 1. So that is your answer. And so if you do have that, which we do right here, 1 point for the antiderivative, 1 point for the answer. So 2 points for part A. Let's take a look at part B. Part B says let T be the triangular region bounded by L. Okay, so T is going to be this region right here. L is a tangent or the slope to the equation y equals x to the n. You're looking at the x-axis and the line x equals 1. So your x equals 1 is going to be right here because that point right here is x equals 1. So here x is equal to 1 at that point. Show that the area of T, which is that triangle, is 1 over 2n. So looking at this part right here, you have this triangle. You know this point right here is x equals 1. I don't know what that point is. So in order for me to find the base, I will have to figure out that point right there. So I can take 1 and subtract from it. However, I do know that this point right here is 1, 1. So I know that the y equals 1. So that this region right here, the height is 1. I know that tangent to the equation y equals x to the n power at the point 1, 1 is going to be y prime. And if I were to go ahead and find the derivative of x to the n, remember how you find the derivative, you bring the n down, you minus the 1. So I have n times x to the n minus 1. And I also know that my x here is x is equal to 1. So if I were to go ahead and find the equation of this line, it's y minus y sub 1 equals m times x minus x sub 1. And so it's y minus 1 equals my m is going to be, I don't really know what it is yet because I haven't actually plugged it in yet. So let's go ahead and do that. X equals 1. So my y prime or my slope is going to equal to n times 1 to the n minus 1. And remember your exponent, it doesn't really matter what number n is going to be. We know n is bigger than 1, but it doesn't matter what the exponent is. 1 to any power is just 1. So what's 1 times n? Your slope is just n. So my slope here is n, x minus 1. I need to figure out what this point right here is, which is this point right there. And if I could find the x-intercept of this equation, because essentially what you have here is this equation is the equation of this line right here. And if I find the x-intercept of this, which is when y is 0, what is x equal to, then I will know the location of this point. So then if I take 1 minus this point, that will give me the base for my triangle. So when I find the area of it, I can have the base because I already have the height. So let's look for the x-intercept of line L, which means y is equal to 0. And I will have negative 1 because y is 0, or you could put 0 minus 1 is equal to n x minus 1. So then let's go ahead and solve for x in this situation, because I need to know what x is. So -1 is equal to n times x minus n. So then I'll have a positive n minus 1 equals n times x, divided by n on both sides. My x is equal to n divided by n is just 1 minus 1 over n. So then I know that at this point here, x is going to be 1 minus 1 over n. So for my base, it's going to be 1 minus this point, which is 1 minus 1 over n. Now to find the area of the triangle, it's 1/2 base times height. So I'll have 1/2 my base, and my base is 1 minus 1 over n, times the height, which is just 1. So here we're going to have to do a little bit of math work. So let's work from the inside out. So that first piece right there is simply just saying it is going to be n over n minus 1 over n, which is the same thing as n minus 1 over n. And then I have the outside piece right there, which is 1. So that is having an n over n minus that, which is going to be n minus 1 over n. N cancels, which is just -1 over n. Okay, so now that we have figured out that this entire thing right here results with -1 over n, let's go ahead and rewrite this. Area is equal to 1/2. We're replacing this entire yellow highlighted part with times -1 over n times 1, which doesn't change anything. Oh, you know what? I made a little typo here. So you see how the minus n, so this is going to be a negative n, but that's going to be a positive one because you have to distribute it, because this negative has to go to both right there. So it's actually a positive. So I'm just going to go ahead and erase this piece right here. So then looking at this, area is equal to 1 times 1 is 1 over 2n. And that is your answer. So for part B, it's for 3 points, 1 point for the slope of the line L, 1 point for the base of T, and showing the area. So just to go back to label, this graph or this line right here is the equation to line L. All right, let's take a look at the last part. It says, let S be the region bounded by the graph y equals x and n, the line L, and the x-axis. You have line L, and you have the x-axis. Express the area of S in terms of n and determine the value of n that maximizes. And when I think about maximizing something, I think about the first derivative of something. So the first derivative area, set it equal to 0, find the critical points. Okay, so looking at this here, in order to find the area of S, which is this piece right here, doesn't it make sense to take the entire area here minus the small triangle that we found from part B, which will give us the yellow region? So it's the big area minus the small triangle, which gives me S. Your big area is from what we found from part 1 was 1 over n plus 1, or part A. Then your triangle that you just found, the area of the triangle from part B was 1 over 2n. So this was from part A, and this is from part B. Part A, the area of the entire region, was 1 over n plus 1. Part B, you found the area of the triangle, which is 1 over 2n. So your area, which is region of S, is going to equal to, if I rewrite this, because eventually I'm going to have to find the A prime, so you don't want to keep it in a fraction. So n plus 1 to the negative 1 minus 1 over 2 n to the negative 1 power. Let's find the first derivative. The first derivative is you bring down the negative 1. So you have negative n plus 1 to the negative 2 power minus, bring down the negative 1. Negative times the negative is a positive 1/2 n to the negative 2 power. Ultimately, I will have to solve or set this equal to 0 and solve for n, because n is the critical point, right? So I don't want to have a negative exponent. I want to rewrite this so it looks a little bit better. So I'm going to have 1 over 2 n squared minus 1 over n plus 1 squared. To solve for n, I would have to have common denominators. So on the top, I'm going to multiply n plus 1 squared. Second fraction, I'm missing a 2n squared. So then ultimately, my denominator will be 2n squared times n plus 1 squared. But then my numerator, I'm going to end up with n plus 1 squared minus 2n squared. Set this equal to 0 over 1. If I go and cross multiply this, notice how my numerator times 1 is just going to be n plus 1 squared minus 2n squared equals the entire denominator times my 0 is just going to be 0. I want to go ahead and FOIL this out. So that's going to give me n squared plus 2n plus 1 minus 2n squared equals 0. I'm going to move my 2n over to the right side. So I will have n squared minus 2n squared over to the right is going to give me a positive n squared. If I move the 2n to the right, minus 2n minus 1. Now, you could try to factor this, but there is no way that any numbers of negative 1 is going to multiply together to give me a negative 1 and then add it to a negative 2. So unfortunately, if you cannot factor, guess what? You're going to have to use a quadratic equation. So negative b is a negative 2 plus or minus the square root of b squared, which is 4 minus 4ac all the way over 2a. And remember, this is your critical point. You're solving for n. So n is equal to 2 plus or minus 4 times negative 4 is a negative 4, and the negative is a positive 4. So that's 8 over 2. And then, of course, you can factor out a 4 here. So 2 plus or minus 4 times 2. 4 is a perfect square of 2. So n is then equal to cancel, cancel, cancel. 1 plus square root of 2. Or 1 plus or minus square root of 2. So as I look at this here, this is your critical point. It's asking you for the n, value of n that maximizes the area. And you can go ahead and say n is equal to 1 plus square root of 2 is the critical point that maximizes the area of S? And that is your answer. All right, so for part C, there are 4 points, 1 point for the area, 1 point for the derivative, 1 for the derivative sets equal to 0, and then if you solve for n, you have all 9 points. I honestly felt like this one was actually one of the more difficult questions because it requires a lot of visual pieces to this, but overall, it's not too difficult. There is a lot of algebra and there is no calculator involved. I think in a lot of ways, having a calculator really does assist you with this significantly, but if you can't have the calculator, you have to know your algebra very well. All right, you guys, as always, I hope you have a wonderful week. Do not forget to go over the 3 pages, well, actually 1, 2, 3, 4, 5, 6 pages of the calculus cheat sheet. So that way you have a summary of all 6 units that will be on the multiple choice questions for the AP exam. Have a wonderful week. Take care.